Thanks. Okay, so up until now we've dealt with equations. Equations suggest that there is an equal sign in there. Now, oftentimes you're really not that interested in equalities. Like, for example, if you're going out to look for a job, you might think, well, I want to make over $15 an hour. Or if you you want something, like you need at least a certain amount of something, whether it's, I don't know, food or a supply or anything like that. So we oftentimes deal with inequalities, and the real world kind of works that way, right? Where you generally want either a minimum of something or a maximum of something, or at least an amount of something else. So what we're going to do with inequalities is that we're going to find a solution set with that. Now, unlike inequality with linear equations, if we have a solution, it's generally one number. But with an inequality, we have a set. For example, if you want to make over $15 an hour, 15, 16, 17, 18, and so on, 16 and a half, and all that, are part of the solution to that. So we need to find a way to express what that solution set is. Okay, so we have several ways to represent inequalities. You can see the number that I'm talking about, the variable here, x, is in between a and b. And the difference here is that we have either a strict inequality where it's less than, or we have an inequality that includes the equality, so we'll have a less than or equal to sign. So we'll show these numerically or graphically using a few symbols. Now, some of you have learned to use a colored-in dot for the end and then an open dot. And if you use that, that's fine. That's a perfectly solid notation. This is the notation from this particular book. So if it's all the same, I guess Okay, so the way we'll represent these intervals is by using a square bracket where what we mean is that x can be equal to a, but if we want x to be strictly larger than a, we'll use a curved parentheses-like thing. And so then we'll color in the area to show that what we mean is the interval between a and b. So we're dealing with inequalities that deal with one variable. In this case, it's x. So we'll show our solutions on the number line. Now, another way to write these inequalities here is by using either the square bracket or the parentheses and have the minimum, have the lower number and the upper number. It's really important to show the lower number, a, in the first position and the higher number, b, in the second. Now, unfortunately, we only have a certain number of symbols that we use, and sometimes we can get these things confused. Like in the third line here, we have what looks like an ordered pair, like you would place on an XY plot. And it's exactly the same notation, but the meaning is quite different. This one means the interval from A to B. If we were talking about graphs in 2 dimensions, we would talk about the coordinate point x equals A and y equals B. So we have to rely on the context of what we're doing to tell us the meaning. And we deal with that every day, right? There's words in English that have 2 meanings, and you know very well by the context what meaning you intend. And if there's any doubt about it, you can always write, the interval and then write this notation and explicitly say it's the interval. The other way to represent all this is by using set builder notation. Now, this tends to be tends to be a little difficult for some people, but it's actually fairly straightforward how to write a set like this. So the first open curly brace literally means the set of. And then, so if you were to read this across, you're looking at the set of x, and then this vertical line means such that. Okay, so the way I would read this is the set of x such that a is less than x is less than b. So then whatever you put after the such that line is really, anything, any way that you want to express it. And so if you end up with a solution that says x is greater than 3, you can write that as the solution set, the set of x such that x is greater than 3. So it's a little wordy, but it's a precise way to write sets. Now, with the interval notation, it's nice and handy because it's compact and everything. With the set builder notation, this is very flexible, and you can define sets in a lot of different ways with it. For example, you can even define solution sets for equations that have. So I suggest you practice with it a little bit. It's not hard, just think about what it means literally, the symbols. So the only thing you have to remember is that the curly brace is the set of, the vertical line is such that, so you can just essentially write a sentence. On the right side, you use the curly brace again just to close the set. Okay, so it's possible that we have inequalities that are open-ended. And so we would write those, show those as just being where the set begins, and then you can put an arrow on the end to show that it goes on forever. And so if we have the strict inequality, it's the essentially the parentheses, and then you have the square bracket for the inequality that includes the equal sign as well. And so you write these intervals using the infinity sign. Now, one of the things to remember about this is that this is simply notation. It's a way to convey an idea. We normally put a number where that infinity sign goes, but infinity is a concept. That means it increases without bound. It's not a number. You don't do operations on it like we do real numbers. But all this means is that it starts at a and goes on into an infinitely large number. Same thing with this one, and then here we indicate this as negative infinity. And so what we're saying is that the set increases without bound to the left, which means that everything that's less than b is included in that. So the notation for the closed intervals, or the intervals with two endpoints, a and b, are notated essentially the same way that you notate ones that go on to infinity or negative infinity. So from a set builder notation standpoint, all you do is essentially the same thing, except that you would just write x is less than b or whatever it turns out to be here. Now, if you're dealing with all real numbers, if the solution set is an identity, essentially all real numbers works, you can write the interval negative infinity to infinity. You can write all real numbers, or, whoops, or you can write this R that you'll see in your textbook. It looks like this, where it's like a big bolded R, capital R, except that it's hollowed out. So if I write it on the board, it'll be like that. And that also means the set of real numbers. Now, you don't have to put curly braces around that, because then if you were to write this, this means the set of real numbers. And that may make sense to you, but it's really not necessary. It's just like that is the set of real numbers. Yeah, there was a question.
I lost you when you started talking about the negative infinity.
Okay. So what negative infinity means is that when we have this expression here, x is less than b. So let's say x is less than 6. We would graph that like this, showing that our solution set, and perhaps I should have shown an arrow here, like this, that it goes on forever. And what the negative infinity means is that all the negative numbers are included in here, and it goes all the way up to whatever b is, whether b is a positive or negative number, but that's the upper bound. So infinity goes off to increasingly large numbers. Negative infinity goes off into increasingly small numbers. Okay? All right. Okay, so why don't you sketch the graph? Make a number line, put these on the number line properly, and see what you get.
Listen,
Yes.
that you grab this one and that one, all three of them, or just this one only?
We'll do all three of them. You need 3 separate number lines then.
You said we need 3 separate number lines.
Mm-hmm.
Thanks.
Okay, looks like most of you have finished. So you should have something that looks a bit like this. Okay, so the first two go off to negative infinity. The first one starts at 4, then the second one starts at -3, and then -3 to 4 is an interval. On the left-hand side, you should have a square brace, and on the right-hand side, you should have a parentheses. Okay, so let's look at what are the length of these intervals. Okay, so we'll look at some intervals here. And remember, we were talking about earlier on, when I was talking about absolute values, we were talking about distances as always being positive, right? So we take the difference between the two, and we end up with a positive number. So when we have something like 4 to 10, we just take the first number, subtract the second number from it. So you take the larger number, subtract the smaller number, and you get 6. Same thing with the next few. You'll take 13 minus 5, and that's 8. 0 to 7 is 7 minus 0 is 7. And then when you have negative numbers, what you have to do is be mindful of the fact that you're taking the difference between two numbers, and so you have the double negative. So 4 minus that first number, -2, makes it 4 plus 2. Oops, I went too fast there. Sorry. So if you look at these graphically, and I'll sketch them on the board. We're looking at this interval here. And so we take the larger number minus the smaller number. So this length then turns out to be 6. And that's really physically what you're asking when you're asking for the length of the interval. Now I'll skip down to the last one. And so to graph that interval, it's from -2, square bracket, to 4, a curved bracket. So we're talking about this length here. And so this is going to be 4 minus a -2, which is 6. And if you count the units, it's 1, 2, 3, 4, 5, 6. So by treating this negative sign properly, it actually turns out to be adding 4 and 2 to get 6. Okay. So let's look at some properties of inequalities. And inequalities, when you're manipulating them, making equivalent inequalities, operate fairly similarly to equalities, but there's a couple rules that we have to keep in mind. So if A is less than B, so if we have a number that's smaller than another number, we can add or subtract any number to both sides. So adding and subtracting works a lot like manipulating an inequality. If C is greater than 0, in other words, if C is positive and we have this situation where A is less than B, then we can multiply both sides or divide both sides of the equality and not get not getting in any trouble. Now, when C is less than 0, that's when we have our, well, we'll talk about that one in a little bit, but if we have A is less than B and B is less than C, then we have A is less than C. So this is what's called the transitive property of inequality. So that's a little bit like my sister is younger than me and I am younger than my brother, so my sister is younger than my older brother, right? I mean, that's the kind of thing that's addressing. Okay, so let's look at this from the standpoint of trying out that first property. So I have x plus 3 is less than 0. If I subtract 3 from both sides, I get x is less than 3. If I subtract x from both sides, I get 3 is less than negative x, which if I swap that around, negative x is greater than 3. And so if C is less than 0, what we have to do is turn around the negative sign. So you back up to that where I have the x is less than -3 and negative x is greater than 3. These say the same thing. If I were to change the signs here by multiplying both sides by -1, what I'd have to do is change this sign like this to be the same as that one. So the thing that you have to know is that when C is less than 0, the inequality changes. Now the reason for that is that the size of a negative number, in some respects, the larger size of a negative number, -6 for instance, 6 is larger than 3, so -6 is less than -3 because -6 lies to the left of -3 on the number line. So when we're going this way, you know, we go 3, 6. The 6 is larger when we're going this way. We have -3 and -6. Then the -6 is smaller. And so even though 6 is larger than 3 when we have negatives in front of it, it's the other way around, where negative 6 is less than 3. And that's exactly why we have to turn around the sign. So notice that in this case, if A is less than B, if we multiply both sides by a negative number, C, we get AC is greater than BC. And the same applies if we do that with division. So I'll do some examples here to kind of solidify this. Okay, so we get x plus 3 is less than 4. Here we're just going to subtract 3 from both sides, and we get x is less than 1. Okay, so that's perfectly sound. To put that in an interval notation, it's going to be negative infinity to 1. Now most of the time we'll just say this is our solution here. If we want to get, persnickety, we'd write the solution as an interval. Okay, so let's step up the complexity here. If we have 3x plus 7 is less than 2x minus 1, what we want to do is subtract the 7 from both sides. We subtract 7 from both sides, and then we simplify that. 3x is less than 2x minus 8, and then we'll subtract 2x from both sides, and then what we get is x is less than negative 8. Now, remember when I was talking about equalities, I said one of the things that you can do is kind of strategize when you see an equation with a variable on both sides, subtract or move the x's over to the side where the coefficient of x is positive. Then you don't have to worry about flipping the or changing the direction of the inequality by doing so with an inequality. Okay, so you try this one. Okay, let's see. Anybody get anything? Ryan, did you get something?
I got 7 is less than or equal to x.
7 is less than or equal to x. Okay. So you did that by subtracting or adding x both sides,
Yeah.
and then adding 2 to both sides, and you get 7 is less than or equal to x.
Yeah.
And that's a perfectly good answer. If you want, if it just visually is more appealing to you, you can write x is greater than or equal to 7. It's the same thing. Just make sure that when you're moving things back and forth like that, when you turn around an inequality, that you keep the inequality facing the right direction.
I
Yes?
have a question. If I did it the other way, so I just put 5 onto that side and got negative 7 is greater than or equal to x.
It's not greater than or equal to x. When you do it that way, you have, you subtract 5 from both sides,
Yeah.
and you get then negative x is less than or equal to negative 7.
Yeah.
And then you multiply both sides by negative 1, and you get, and then you have to make
And then
it,
just swap it. Okay.
right, like that. Okay, so we end up with the same thing.
Yeah.
Okay, here's another one. Sorry for the small writing there. It's 2 times 4 minus z is greater than 8 times 1 plus z. I'll write it larger on the board if it's too small in the back. Okay. Anybody get anything on it? Jaslyn, did you finish?
Yeah.
What did you get?
0 is greater than z.
0 is greater than or equal to z. Okay, so how did you do that step by step?
I distributed the 2,
Mm-hmm.
and then I distributed the 8 on the other side.
Okay.
And I added 2z to both sides.
Added 2z to both sides. So
And
it's
then-
looking like that, right?
Yes.
Okay.
And then I subtracted the 8 from both sides. And then divided the 10. Okay, these are those ones.
Great. Okay. Yes.
Do you want us to write our answers also bracket in parentheses?
If I ask you to, if I say, show your answer in interval notation, then you would write it like this. If I were to say, show your answer in set builder notation, then this particular one would be z such that z is less than or equal to 0. Interval notation, of course, would be oops, 0. Now, whenever you use either positive or negative infinity, it's always the parentheses. But either of those, this is set builder, and that's interval then. All right. Okay, double inequalities. Sometimes you have something like this. And the way this reads kind of from a natural standpoint is that you want a number to be between two things. Like, for instance, if you're calculating time, I want to be between an hour and a half, something like that. So these double inequalities come up quite naturally. So when we have them, what we can do is separate them into two equations, or we can keep it as two inequalities, or we can manipulate it as a single inequality. The thing that we have to do is everything that we do to each member, we have to do to all the sides. So in this one, all we're doing is subtracting 2, and so we make sure that we subtract the 2 from the left side, so it's negative 3 minus 2, subtract it from the middle, and subtract it from the right side, 6 minus 2. And so our solution then is negative 5 is less than or equal to x, which is less than 4. Now, when you're doing these, make sure it makes sense. And what I mean by that is, if your inequalities are facing the opposite direction, chances are it doesn't really make sense. For example, if you have something like this, where you're saying 3 is less than or equal to x, which is greater than 4, you know, something like that, where you have this, you don't ever want that. Now, it may make some sense to you if you're reading this. If you need to make inequalities that face different directions, make it as two statements, where you're going to say x is greater than, and then you say x is greater than 4. These are two different statements then. They don't relate, so don't put x in the middle of both of them, because it doesn't really make sense. And oftentimes is contradictory. Okay, so let's look at one that's a little bit more complicated. We have a negative 7x in there. So we have negative 10 is less than or equal to 4 minus 7x is less than 10. So the first thing we want to do is get rid of the 4 in the middle, and so we're going to subtract 4, and then we'll simplify that. Let me pause here for just a moment. Okay, so now we have negative 14 is less than or equal to negative 7x is less than 6. So we want to divide by negative 7 on the next one. Or first we'll divide by 7, I suppose. Yeah, we'll let that play out. So what we have is when I change the negative to a positive, on all of these, and then on this last one, the positive goes to negative, I change the direction of the inequality. And that's okay, but it's not the way that you would normally look at something. You don't say 2 is greater than or equal to x is greater than negative 6 over 7. Here you really do have a preferred direction where you go from smallest on the left to the largest. So you just swap the whole thing around, swing it around, so negative 6/7 is less than x is less than negative, or is less than or equal to 2. Okay, so this is still correct, and it does make sense, and it's not that it's wrong, it's just that this one I think flows a little bit more naturally, where you go from smallest to largest, left to right. Okay, so here's one for you to try then. You can pretty much follow the same steps in this. Yes.
So on the last one you did, you said you should make it smallest to largest. How, like, when you're doing that, what's like a tip to like not mess up your signs?
Once you're here and you're convinced you're right, it's just instead of going from largest to smallest, you're going to write from smallest to largest, and so you just start on this end and you write everything in this order, recognizing that you have the less than sign here and the less than and greater, less than or equal to sign here.
Aren't they flopped though?
Well, now from here to here, there's no change because I've just moved everything around. For example, when I have just the one side where it's x is less than 2, I can write 2 is greater than x, right? So I'm just turning the whole thing around. So if this was 0 is less than x, which is less than 2, then you would have x is greater than 0 here. So you just swing the whole thing around like that.
So, I know mathematically it means the same thing, but physically, you've switched them.
Well, it does mean the same thing, okay, and so it's really, if I'm reading it from right to left, I'm saying 2 is greater than or equal to x, which is greater than negative 6/7, right? And that's the same thing if I'm reading it from left to right here, right? 2 is greater than or equal to x, which is greater than negative 6/7. So all you have to remember is when you write these, you write them in the opposite order, and then the inequality sign, it stays paired up with its, the negative 6/7 and the x. That's a strict inequality, and then you have the equality sign between the x and the 2. And then you just look at this and you say, well, the 2 is the bigger one here, 2 is the bigger one here. And I always remember that with the inequality, that the open sign is the bigger side. Okay, does that answer your question?
Mm-hmm.
Okay.
I was just like, instead of like having to like go through and read each one and then write it backwards, I was wondering if you could just flip the sign, just make it quicker, but it's okay, I can just read it.
Okay, well, how did you do with this example here, or the
I
you
just
tried?
finished taking notes, so I haven't started yet.
Okay, all right. How about somebody else?
I did probably.
Okay.
So first I subtracted 4 from both sides.
Okay.
Then I divided both sides by negative 2, and that's, well, flip the entire sign over, and
Oops. Wow.
Oh. Yeah, there we go. That's what I got.
Like that. I guess my writing is a little small here. Yeah, that's a little better. Okay. Any questions along this? Stepwise, it's exactly the same as this other one here, except here I'm doing getting rid of the negative sign right away by dividing by -2, and so just like Aaron said, it flips the inequality when you divide by a negative number. Okay. Okay, so we have this concept of and or. All right, so if I said everybody with sandals or a sweatshirt stand up, if you happen to be wearing sandals and a sweatshirt, you would stand up, right? So it would be all of those of you that are wearing sandals, all of you that are wearing sweatshirts, and all of you that are wearing both. If I say all of those of you that are wearing a sweatshirt and sandals, if I asked you to stand up, you would have to have both in order to stand up, right? So this and or, what I'm introducing here is that when you say and, both of the statements have to be true. If I'm going to say or, either can be true or both of them can be true. We don't have what's called an exclusive or. We're just going to use or in the ordinary sense of the word. So if I have two equations, both of these have to be true. And so if I solve them independently here, we have x is less than 4 is on the left side, and then I solve the right side by subtracting 8 and then dividing by 2. I have x is less than or equal to 4 and x is greater than -1. Now if you think about that on a number line, it's possible that this is true. Like for instance, if x equals 0, well 0 is less than or equal to 4 and 0 is greater than -1, so this represents an interval, actually, right? So they both can be true. So we can write it as a single inequality with two inequality signs in there. So all the numbers between -1 and 4 would make that true. So here's another one. 2x plus 1 is greater than 3, and x plus 5 is less than 2. So I'll solve the left side first, and then I'll solve the right side. And here I get x is greater than 1, and x is less than -3. Now that can't be, right? There's no number that's both greater than 1 and less than -3. Any number you try will fail in one or both of those. So in this case, what we're going to say is that there is no solution to this. Now, if I did or, though, it's very well possible that we have both true, or that either one can be true at any given time. Not both of them, but one of them. For example, if we're going to, let's say, choose a number, -4, well, -4 is less than -3, so that side works. If we say x is 10, well, x is greater than 1, so that's true. Now, the way we notate that is that we put two intervals, and we make this the union. Okay, so we're going to have a couple symbols here. We have and, which is the intersection, so that means both of them have to be true. And we have or, which is the union. That means either of them can be true. Now, the way you remember this, at least the way I remember it, is that the intersection is and this one, if you cross this, you get an A. So you know that intersection is and. The other one is union, and of course U reminds you of union. So if you remember U goes with union, and this upside down U goes with and, then you'll get the whole set properly by remembering that as an A for and. That's how it connects it. Okay, so let's look at an application here. So the perimeter of a rectangle should be between 30 and 42 centimeters, and the length is 12 centimeters. What is the width? All right, now it doesn't say exactly what the perimeter is. It says it's between two numbers. And so we're going to expect that we have an interval for the solution here. Okay, so W is the width in centimeters. The perimeter is 2 times 12 plus 2W. Okay, so you see this is the first and second steps in problem solving. I make a diagram, I define my variables, and I set up my my model, how you calculate a perimeter. And so now what I have is I can set up my inequalities by saying that I want to be between, I want the perimeter to be greater than 30 and less than 42. And so then from here I can solve. So by solving this first one here, I'm going to subtract 24 from both sides. I get 2W is greater than 6. I get W is greater than 3. And on this side, I do exactly the same steps. I subtract 24 from both sides and divide by 2. And so I get W is less than 9. Now this we're going in a range, so you expect that you're between two numbers, and in fact that's what your solution tells you. So you can write it as the width is between 3 and 9. Now I wrote this as a strict inequality, and if you're going to say it should be between 30 and 42, it's perhaps the equality will still work. So I could have put this as 3 is less than or equal to W is less than or equal to 9. So that's kind of a fine point on this one, whether you include the endpoints or not. Okay. So then the answer is the width should be between 3 and 9. You don't have to spell out 3 and 9. You could write 3 and 9, of course, but the normal English way to write numbers less than 10 is to spell them out, not to write the numeral, right? Yes?
I'm confused. How'd you get 12 on the picture of the rectangle?
The length is 12 centimeters.
Oh, sorry.
That's okay.
So, okay, then you find the perimeter by doing 2 times 12.
Yeah, you add 12 and 12 and W and W.
Because it's 2L plus 2.
Yeah.
W.
Okay, so the perimeter is simply the sum of all the sides. Okay, any questions on that?
Just one. I was just writing. How did you choose 30 and 42?
Because that was my problem asked that the perimeter is between 30
Oh,
and
right,
42.
sorry. I don't like that. Cool.
Okay, so this one has all the 5 steps, right? I made my diagram, gathered my information, I defined my variables, I set up my equations, I solved the equations, and then number 5 is I answered the question. Okay, so it doesn't matter that I chose W as the width. I'm not going to answer this question as W is between 3 and 9. I'm going to say the width should be between 3 and 9. So that's one of the reasons why I'd like you to answer in a plain English sentence, is because nobody really cares how you define your variables. It's important that you do define them, and if you want to look at the calculations, then it becomes important. But the answer is simple. The answer uses a word that's in the question. Okay. this will overlap with next Friday's lecture. We'll continue this, is absolute value equations and inequalities. Now, absolute values come up very naturally with inequalities, because remember, the absolute value is a good way to ask, what's the size of something? And of course, inequalities, often you want the size to be less than something or greater than something. And so we're going to eventually get there. But let's first start out with equalities with absolute values. Now, the absolute value of x equals 3, there's two possible solutions to this, right? X can be either 3 or negative 3. And so the way we're going to do this, and there is a shortcut that everybody takes, but I want to explain where the shortcut comes from, is that the absolute value sign will either leave x alone, or if x is negative, it'll make it positive. And so if x was negative 2, it actually makes it negative 2. So we have two possibilities, that either x is 3 or negative x equals 3. And so then when we take care of the negative on the x, we get x is negative 3. So we can directly put that in there for our solution. So if we were to take something just a little bit more complicated, x plus 3 in the absolute value of x plus 3 equals 5, we have two equations that come out of that. If x plus 3 is less than 0, then it's going to change the sign where the absolute value signs are. If x plus 3 is positive, it's not going to do anything. The absolute value signs are going to go away. So we write this as two different equations, and then we solve them. So let me talk about this one first. This is where x plus 3 is positive. So it makes no change. So we just set it up like a regular equation. And so we subtract 3 from both sides, and we get x equals 2. And sure enough, if we check it, if we say 2 plus 3 equals 5, absolute value of 5 equals 5. So that works. Now in the second one, it's possible that the absolute value sign changes the sign if x plus 3 is negative. And so we'll put a negative on there, multiply both sides by negative 1, and we get x plus 3 equals negative 5. And so when we subtract 3 from both sides, we get negative 8. So if we put negative 8 back in here, we get negative 8 plus 3 is negative 5. The absolute value of negative 5 is 5. Okay, so usually that you skip this and you go right away to x plus 3 equals negative 5. So you set up two equations, one where it's normal, the other one you still set what's inside the absolute value sign on this side, but then it equals, you change the sign of the right side. Because you almost always will multiply this by negative 1 to get to this. There was a question, I'm sorry. Okay, so it's okay to change that step, but just remember where it comes from, because it's going to be really crucially important when we are dealing with inequalities, because we're going to do more than just flip the sign of that one side. We're going to change the direction of the inequality. Okay, so you try. This is an easy one. It's just like the last one. Okay, so what do you think? Anybody get it?
X equals 5 or x equals negative 7.
Okay, great. So how did you set it up? What was the first equation you had?
I just had x plus 1 equals 6, or x plus 1 equals negative 6.
Okay, so you set it up like that, and then you just solve them. Okay, and we can check it by putting it in, and we get it exactly right. Okay, let's try the next one. Here's one that's a little more difficult. Okay, anybody get anything? I noticed a few of you stopped. Did you get something?
A equals 2/7 and A equals -2.
Okay. All right. So, what was the initial equations here?
So the first one was 7A plus 6/4 equals 2. And the second one, I did -7A minus 6/4 equals 2.
Okay. So did you keep it in parentheses? Maybe I should have you write it on the board. Actually, let me write this. This was the first one you came up with. And then the second one, you came up with, but you put the negative sign in front of the 7 or in front of the whole thing?
Well, instead of like putting it in parentheses and like distributing it, I just did -7A minus 6.
Ah, okay. So essentially, you did -7A minus 6/4 equals 2. Perfectly good. Okay, so those are equivalent equations. And then you multiplied by 4 both sides?
Yes.
Okay.
So get rid of the 4 and then just subtracted 6 or added 6. And then divide, and then A equals 2/7 and A equals -2.
Like that. Good. Okay, so there's several routes you can take. So long as you set up that first one, understanding what the absolute value sign does, you change the sign of either side. The important thing to remember is that the negative is over this whole expression, and so she was right in distributing this negative to both of them. Okay, so if we check this, we find that this works.
Do you have to know how to check it?
Well, checking, you should be able to do that, basically substitute it in, and you just do it twice if you have 2 answers. I used to insist that you do that, and I found that if you get into more substantial questions, that you get sometimes some very awkward fractions, and that checking turns out to be more computation than doing the original problem. So I think, it's a good thing to know how to do. I'm not going to, ask you to explicitly do that, because the problems that I'll give you probably will end up with a fraction, and dealing with all the fractions just takes time. I think you're much better off just carefully checking step by step. Okay, so that's where we'll stop, and we'll continue there on